Today we're going to review for Standard 3. The first topic is multiplying fractions. So if we have two fractions like 2/3 and 3/4 and there's a dot in between them, that means to multiply them. And we take the top row straight across, 2 times 3, and the bottom row straight across, 3 times 4, and this gives us 6/12. If you want full points, you'll have to reduce this to the simplest form. They share a common factor of 6. So if I take 6 divided by 6 and 12 divided by 6, this reduces to 1/2. Other ways of showing multiplication might be to use an asterisk instead of a dot. Either one mean to multiply. In algebra, we try to avoid using an X because that's very confusing with all the variables everywhere. The good news is, for multiplying, it does not matter if our denominators are the same. The steps are very straightforward. Multiply straight across. 3 times 5 is 15. Multiply straight across. 7 times 2 is 14. In this case, 15 and 14 do not have any common factors. When I say factors, we're looking for numbers like 3 times 5 that give us 15. Does 3 or 5 multiply into 14? No. Factors of 14 are numbers like 7 and 2. Because they don't share any common factors, this is already the simplest form, so we leave it as is. What about when we have negatives, like 2/7 times a negative 3/2? The negative should stay on the top of the fraction. So even if it's written like this, a negative in front, it belongs with the 3, like so. So we take 2 times a negative 3, and these two numbers have a different sign, so the result is going to come out negative. And then we take 7 times 2 and we get 14. When we look for common factors of 6 and 14, remember they are both even numbers. All even numbers have a common factor of 2. So that means I can divide both the top and the bottom by 2. And negative 6 divided by 2 is a negative 3. And 14 divided by 2 is 7. And that's my final answer in the simplest form. The next concept is dividing fractions. Not quite as easy as multiplying, but the steps are very similar. A general truth in math is that when you divide by a number, like 8 divided by 2, that is equivalent to multiplying by the reciprocal. So 2 over 1 becomes 1 over 2. That's the reciprocal. Divide by 1, multiply by the other, it's the same thing. In both cases, we get 4. This is useful in a situation like dividing fractions, because instead of taking 2/3 divided by 1/2, we can change this problem. And it turns out that dividing by 1/2 is the same thing as multiplying by the reciprocal, or multiplying by 2 over 1. So if we want to, we can go back to our original problem, and instead of dividing by 1/2, we're going to multiply by 2 over 1. And now we're back where we started, multiplying fractions. 2 times 2 is 4, 3 times 1 is 3. They don't share a common factor, so our lowest or simplest form answer is 4/3. Let's take another look back at that problem, 2/3 divided by 1/2. I showed you how you can multiply by the reciprocal, or multiply by 2 over 1. A common technique to make this a little faster is to instead cross-multiply. If you take 2 times 2 on top and 3 times 1 on bottom, that's really the same thing. And here's the proof. Instead of dividing by 1/2, I multiplied by the reciprocal, 2 over 1. And notice I get 2 times 2 is 2 times 2, 3 times 1 over here, and it's the same thing. So to skip that step of multiplying by the reciprocal, we can instead cross-multiply. A common mistake is that students do this in the wrong order, and they put 3 times 1 on top and 2 times 2 on the bottom. So if you want to avoid mistakes, consider multiplying by the reciprocal instead. But if you understand how the cross-multiplying should be set up, feel free to use that method. For both of these, that again was 4/3. The next concept for Standard 3 was adding fractions. and these are a little more complicated. The general idea behind adding fractions is that we have to have the same number on the bottom of the fraction. That's called the denominator of the fraction. When we do, for example, 5 over 13 plus 2 over 13, that allows us to add the top straight across. 5 plus 2 is 7. But we keep the bottom number the same. We don't combine those and get 26. The unit of 13ths stays the same. If that's hard to conceptualize, here's a visual example. Consider a 4-slice pizza. The red here represents 1/4 of the pizza, and the 2 green slices, well, I don't know if I would eat green pizza, but they represent 2 out of the 4 possible slices. If I add together 1 and 2, how much of the pizza do I have? 3 out of the total 4, not 3 out of 8. What about then when I have different numbers on bottom? For example, here I have 2/5 and 3/10. Can I add straight across and get 5 over something? No. When the denominators are different, I have to change one of the fractions to make them the same. So the question I might ask myself is, how do I get from 5 to 10? What could I multiply by? 2, right? When we convert fractions like this, we have to multiply both the top and bottom by 2. So 2 over 5 becomes 2 times 2, 4, 5 times 2, 10. And these two fractions, 2/5 and 4/10, are equivalent. It's just a larger form of the same fraction. So I'm going to take this 4/10 and replace my original 2/5 with 4/10. Remember they're equivalent, so I can do that. And now the denominators are the same, so I can take 4 plus 3, and I have 7/10, and that is my final answer. There are some situations with fractions where it's not as simple as changing one fraction. For example, can I multiply 3 by something to get 4? The answer is no. So for fractions like these, I'm going to find the least common multiple for the denominators. So for 3 and for 4, I'm going to look for the least common multiple. And how do I do that? Let's start with the larger number of the two, 4. If I multiply that by 1, what do I get? 4. Does 3 multiply into this number? No. What about 4 times 2? I'm looking for all the possible multiples of 4. That's 8. Does 3 multiply evenly into 8? No. What about 4 times 3? That's 12. Does 3 multiply evenly into 12? It sure does. This tells me that I want my new denominator for both fractions to be 12. So if I'm changing this fraction to thirds, how do I get from thirds to twelfths? What do I have to multiply to get from 3 to 12? I have to multiply by 4. To keep this fraction the same, if I'm multiplying the bottom by 4, I also have to multiply the top by 4. And this new fraction becomes 2 times 4, 8, 3 times 4, over 12. That's going to replace this fraction here. Next, I will do the same thing with 3/4. The question becomes then, how do I get from the denominator of 4 to the denominator I want of 12? 4 times what gives me 12? Well, that answer is 3. And if I'm going to multiply the bottom of the fraction by 3, I have to multiply the top also by 3 so that it stays the same, or stays equivalent. And this gives me 9 over 12, which I'm going to replace up here for this fraction, 3 over 4. So now my original problem has changed slightly, but these fractions are equivalent to the original ones. But now my denominators are the same. So I can add straight across the top. 9 plus 8 is 17. The bottom stays 12. That's just the unit, and there is my final answer. The last and final concept is subtracting fractions, and these work very similar to adding fractions. In the event that I have two fractions with the same denominator, I can subtract straight across the top. 7 minus 5 gives me 2/8. And I can simplify this by dividing the top and the bottom by the same common factor of 2, and this gives me 1/4. However, if I have a situation like 3/4 minus 1/2, I cannot subtract straight across the top because the denominators are different. a 4, and a 2. The quick fix is to look at the smaller number, 2, and ask myself, can I multiply 2 by something to get 4? And the answer is yes. If I multiply 2 by 2, I get 4. Since I'm multiplying the bottom of this fraction by 2, I also have to multiply the top of this fraction by 2. And my new problem becomes 3/4 minus 2/4, because 1 times 2 gave me 2, and 2 times 2 gave me 4. So I subtract the top, or the numerators, straight across. 3 minus 2 gives me 1. And the bottom stays the same. It's just the unit. What about a situation like 3/4 minus 2/5, though? Can I take 4 times a number and get 5? No. When adding fractions, I showed you how to find the least common multiple for numbers like 4 and 5. We're going to use that technique again. We're going to begin with the larger number, 5. And 5 times 1, or the first multiple of 5, 4 does not go into evenly. What about 5 times 2? Does 4 multiply evenly into 10? No. What about 5 times 3? Does 4 multiply evenly into 15? No. What about 5 times 4? Does 4 multiply evenly into 20? Yes. And what you might notice is that the 5 here in the bottom right is what we multiply this fraction by. So the denominator from the fraction on the right, we multiply the top and the bottom of the fraction on the left. And similarly, we take this 4 from 3/4, and we're going to multiply the fraction on the right by 4 and by 4. If I take 3 times 5, I get 15. 4 times 5, I get 20. 2 times 4, I get 8. 5 times 4, I get 20. Now that I have the same denominator, I can subtract straight across. 15 minus 8 gives me 7/20. And that is my final answer.